So we're opening up the brushed metal start max scene, which is included with this Q&A, and let's just have a quick look at what we've got within this scene. We've got three kind of spherical objects which are multiple parts. There's several kind of these cap end objects, and also some additional paneling going on here, and some stems and screws and rivets and so on and so on. So these are all instant, so this object is exactly the same as these guys and so on. We've also got a ground plane which has got a matte shadow material assigned to it, which is this guy, which has got the camera matte background, which is this KC outside high HDR map, which is applied to the environment as well. Just pull that across. There we go. This guy here, which is spherical mapped, and we've got a low res version of it for the light source here. This guy in here. So let's just do a quick test render. Let's bring this across, and there we go. So it's churning through the scene, and render times aren't too bad. You're looking at something along the lines of around about 20 seconds or something like that for the scene to render out. Just wait for this thing to finish. Okay, so well, 30 seconds, 31 seconds for this to output. Now this is basically just my box standard quad core testbed machine, so it's not that high spec or anything like that, so we haven't got like a ton of buckets. So obviously the faster machine, obviously the render times will be considerably lower. Let's just pull up the materials, because that's kind of where we're actually going to be doing our optimization. I'm just going to bring that down so we can see all the rollout at the top there and at the bottom. Let's pull that down to there. Okay, so this is the brushed metal this brushed metal material which is assigned to these objects. Now this is the brushed metal preset which is included with 3ds Max. So what I'm going to go through is I'm going to go through and tweak all the parameters within this particular material, and also this chrome one, which again is the standard chrome metal one, which is included with the software. So again, I'm going to go through and tweak it to make it, well, what I would feel a little bit more intuitive, a little bit better, and also go through and change some of the advanced rendering options in this rollout here. Okay, so the first thing I want to do is I want to go through and just change some of the initial parameters. Like for example, this diffuse level personally I feel is a little bit too high. Metal's base parameters doesn't have any diffuse values. It's all driven by reflection, unless you've actually got some kind of surface coating like fingerprints or any kind of lacquer that's applied to it. So this diffuse value can come all the way down. So I'm going to drop that down to about 0.05, and I'm also going to drop this color down a touch. Now you'll notice this material is getting quite dark. However, we're going to tweak that in a second anyway. Okay. Roughness I'm going to leave as is, because the roughness is simply driving the diffuse level and the diffuse color. Reflectivity I'm actually going to increase to about 0.95, so it is quite reflective, and obviously that's going to bring it up a touch. However, what I'm going to do here, which is also going to be bringing this up a little bit, is to ditch this map, which is a noise map, which is automatically assigned to the material from the preset. Now what this simply does is it's driven by the map channel of the objects. Now we have some mapping applied, so I'm going to take this out to start with, and we can always put it back in afterwards. So what it's simply doing is making sure that we've got this kind of stretchy effect going on by having this tiling set to 100. It's pushing these values. If I just take this down to, say for example, to 1 and 1, you can see what it looked like originally. Then obviously by increasing the tiling, we're getting these more kind of streaks. I mean, what you also could do is take this value, this size value, down even further and drop this U tiling down to 0.001, for example, and we'll get the similar kind of effect. One thing we do want to make sure of, however, is this side meets that side, so it tiles perfectly, otherwise you will get a seam. Now in this particular example you may actually get a bit of a seam in here. Let me just pull that up to about 0.5. You might get a little bit of a seam going on here. I'll just offset this as well just to see. No, it maybe just a fraction, of a seam going on, so we might need to tweak these values further just to make sure that we don't get any kind of visible lines in the brush metal effect. So for the moment what I'm going to do is I'm going to pull this map out of this color slot here. We'll make any kind of tweaks and changes to the main material itself, and then we can always bring this back in afterwards. So I'm just going to get rid of that. Okay, so now we've just got this material on its own that's not driven by any submaps within the reflection or diffuse or anything like that. Okay, so I'm just going to go through some of these parameters here and we'll see, we'll make some changes in a second. So reflectivity, like I say, I've amended that to 0.95. Glossiness, I'm just going to leave that as is at the moment, and also the glossy samples. Now the glossy samples is the key area which is going to affect your render times. The more the less you actually drop this down, the more the samples are going to be spread out. So you're going to get more kind of a diffused effect. If I drop this down, for example, you can see these kind of samples spreading out, but you're also seeing it's starting to get very, very pixelated. So the more I drop it down, the more I'm actually going to have to increase this to actually get like a decent result. And you can see the actual time even taken to update this material slot is increasing. So these are the kind of two areas that we need to balance. There's one additional thing which I'll come to in a second, which is the anisotropy value down here, which also spreads out the samples, but like I say, I'll cover that in a sec. So for the moment I'm just going to leave this around about 0.8, which is not too bad. It's not a bad spread for generic kind of brush metal materials. When you've, say for example, you've taken a chrome surface and got a bit of a wire wool or a scouring pad to it, for example. So at the moment, like I say, I'm going to put this back to a value of 8. Okay, the reflection brightness is obviously driven by this reflectivity value and also this color swatch here. Now we can add, say for example, a very slight amount of color to it, but if we go a little bit too overboard, then we are going to start dulling this material down, which we don't want to at the moment. So just adding a slight hue to it gives it a little bit of a kick. This metal material flag here, again, if you hover over it, it basically tells you exactly what it needs to do, which is, if you just call it, it says when on the color reflection comes from the main diffuse color and the reflectivity parameter sets the balance between the diffuse and the glossy mirror reflection. So in essence what it's saying is that the diffuse value, the diffuse color also drives the reflectivity color. So we can simply copy that in there and we'll get a little bit of a hue in there as well. You can see that color changing slightly, so we just need that to be pretty subtle in this instance. Okay, I mean you can actually have this set to white just to have no color within the actual brush metal. I like to have a little bit in there just to give it a little bit of a hue. I mean we can also take that down if you decide to output that to a compositor anyway. You can also increase it as necessary. Okay, like I said, these glossy samples we're going to increase in a sec once we've actually got the initial render out the door. Anisotropy, like I said earlier, is to spread the reflection based on either normals, which is obviously automatic here, or it can actually use a map channel, which, as I said earlier, we've actually got some UV coordinates assigned to this, just basic cylindrical mapping assigned to it. So because this is set to a map channel of 1, we can also use a map channel of 1 within this material, so therefore the anisotropy is going to be distributed based on these mapping coordinates. However, for the minute we'll just leave it on automatic just for the moment. Currently, the based on the preset, like I say, the brush metal preset, the BRDF curve is driven by this custom reflectivity function, which is user defined, so we can drop that and increase it, or so on and so on. However, this doesn't really give like a realistic fall off. We've got setting here, which is obviously the 0 degree reflection, which is basically face on. It's set to a strength of 0.9. You can go from 0 all the way up to 1. So that we've got almost full reflectivity when we're parallel surfaces to camera, and on the perpendicular we've got this full strength, because obviously it's set to a value of 1, and this curve is obviously set to 5, which you can amend and smooth out and so on and so on, or clamp off, or whatever you want to do. However, a more realistic approach is actually driving it by the index of refraction. So we can just enable that, and then you'll notice that the material changes all the way back to black virtually, and the anisotropy is completely screwed. However, what we can do now is change this index of refraction value. Now, you'd normally think this is just basically for refractions, because obviously it's located within the refraction group. However, in this particular material, this architectural and design material, we can actually pull this all the way up to, well, I think we can clamp it all the way up to a value of 50, which gives nice kind of chromy surfaces. However, we can drop this down slightly, say we can drop it down to 25, for example, and we're starting to affect the distribution curve here. So if you notice that if I increase this guy, you'll start seeing that the facing reflection, the surfaces which are parallel to camera, is starting to get a little bit closer to 1, so it's a higher strength. But you'll notice that it curves off here down to, well, around about 0.6, give or take a few values. And then you'll notice, if you could actually physically zoom into this, unfortunately we can't, you'll notice that it kind of dips down and then goes up right on the perpendicular, literally right on the perpendicular to the surface. So if I pull that all the way up to, let's say around about 40, okay, and we'll have a comparable setting within here in a second, which for the actual chrome screws, which I'll sort out in a second. All right. I think any optimization within this advanced rendering options we'll leave for a second. Let's just do some amendments within here, and then we'll go through and make some changes within these additional rollouts. So within here, I'm just going to quickly go through and make some additional changes within here. So for example, again, I'm going to drop this diffuse value down to a pretty low value here. Reflectivity, I'm going to leave at 1. Glossiness, I'm leaving at 1. That basically means that there's only one ray that's actually being shot out from a surface, as opposed to, for example, 8 rays which are being shot out from surfaces which are got this material aside. Basically, because we're getting like a mirror surface as opposed to a diffuse surface, so we only need the one ray that's been shot out. So we need to tell it that it's a metal material as well, and you'll notice again that the swatch changes, so therefore it's driven by this diffuse value, so that needs to come up. So I'm going to push that all the way up to white, and I'm not going to give it any additional kind of hue for the reflection. Okay. Last thing I want to sort out in here for the moment is, again, changing it to by index of refraction, and I'm just going to crank that all the way up to 50. That should give us a nice result. Anisotropy, I'm going to leave that as is, so it gives us a nice kind of pinprick highlight. These pinprick highlights are only kind of driven if you've actually got scene lighting, like for example, if you're not dealing based on either image-based lighting or skylights, for example. If for example, if I've got a photometric light within here, for example, like a target light or a free light, then you'll start getting these highlights. Otherwise, everything is based on reflections, okay, which as it is in real life, for example. Okay, so if I just knock out another sample here, we should start noticing some slight differences between our previous render and our new one. So we're starting to get some nicer reflections within this material setup. Now, the issue is, however, is we are still getting these grainy effects within the material, within the actual reflection. However, this is due to the reduced amount of samples within the material itself. So if we just wait for this to finish, okay. So now we can go through and start optimizing this down. So first thing we want to do is let's go down to, first thing we need to do is check these special effects, check these additional elements. Because we used a preset, we're using values and settings that have been determined by a third party. We're not actually using the default values that were set by a standard architectural and design material. If I just create one quick in here, you'll notice that there are some, just pull this across, there are some parameters in here which are enabled and some which are disabled by default. So for example, obviously this BRDF curve, and also in here in some presets, for example, say for example if I pull up rubber, we have, for example, highlights and final gather only. You might also get some other areas, like for example ambient occlusion is enabled, so we get actual ambient occlusion based on material basis as opposed to a scene basis. So bear that in mind when you're dealing with presets. So let's just quickly just dive back to our brushed metal material. So again, checking through these guys, making sure we don't have anything turned on by accident. What I'm going to do is I'm going to set the max distance. Now the thing to bear in mind here is that objects that are far away, like for example further out over here, anything that's being diffused heavily within the reflection that we aren't going to see can be, in essence, not necessarily removed but restricted or reduced, which is going to help with render times in the long run. So what we can do is we can enable this maximum distance. You can fade the reflection to an end color. We're going to leave that as is at the moment, because by default, if I don't actually enable this, it's just going to go to the environment color, which is black anyway. So to determine this fall off or maximum distance value here, what I can do is just quickly within the scene itself let's create a geosphere. I'm going to have auto grid turned on, and then what I can do is just create a sphere here to determine a value. Okay, I don't think I want it any kind of higher than around about, let's say 60, so we can see here there's only certain surfaces that I want to have reflected. So from here we're going to get some reflection of these objects here within this surface here, but we're not really going to have anything from this object over here, and vice versa, quite simply because it's too far away and the resulting we don't really see this object within this object anyway. So you notice it's very, very diffuse, so we can't really make it out. So what I'm going to do is dial that value, which is, let's say 70 just for safety. Okay, I'm going to cancel that. I'm going to set that to 70 within there. That will do within this particular one, just for a basic example. So if I now, actually, you know what, I think I'm going to take this down a little bit further. I'm taking it down to 60. So if I get rid of this sphere that I've created and then chuck out another render. So the previous render time was 37 seconds. So now we should have something a little bit less. We might be able to take this fall off value down even further actually. Okay, so render's finished, and the render time has actually come down to 29 seconds, even though we have virtually no difference within the actual end render as well. Now, the other thing to bear in mind is don't forget that any other reflective materials within the scene are also going to be reflecting these 8 glossy samples. So this is a reflective object, and also this rubber material here that I've assigned to these rubber seams, for example, in the scene, have also got a reflectivity, and have also got 8 samples of their own. So these guys need to be clamped off as well. Now this rubber one has already got a clamp off of 25. Now that can actually be reduced. We can actually take that down even further, because we only really want kind of like the environment and a little bit of adjacent brush metal material reflecting within this rubber. Any kind of surface has got a reflective property, which is how you get the highlights and fall off, for example, in shading. However, we don't want this too intense, we don't want it too strong, which is obviously going to help render times as well. One other thing to actually do within this material is we can also restrict the amount of bounces that is happening. Now, by default, we're actually saying the maximum trace depth, the maximum number of bounces within the material, is currently set to 8. However, that is being clamped off by the renderer values in here. If I just pull up the renderer settings, we've got the maximum trace depth is set to 6, with the maximum amount of reflections is 4. We can take that down even further. We can either clamp it off within the main scene here, or we can just restrict it within the material. So I think within the material should suffice for this particular instance, because we might want additional bounces within additional objects within the scene. So this maximum trace depth, I'm actually going to take that all the way down to 2. Okay. If I just do another quick render, we should see this render time drop down even further. So previously we were on 29 seconds, 30 it's clamped off at. Now here we should have another drop within render time. Okay, so we've shaved another couple of seconds off, so we dropped it down to about 27 seconds. Okay, so the other thing, like I mentioned previously, is that other materials are also going to be reflecting these samples driven within this material. So what I need to do in these materials is also do something similar to what I did momentarily ago in here. Okay, so this chrome material, I need to drop these maximum distance in here as well, and to take that down. So I've got a value of 60 in here. I think I'll drop this down to let's say 50 in there, because these items are pretty small. We can't really make out these kind of adjacent objects really anyway, so actually I think I might be able to take that down to about 40 as well. Trace depth, I'm going to take that down to 2 again. Okay. Render times again should drop from 27 down a little bit further, a bit of luck, but these guys are quite small, so it might not shave that much off. Actually, you know what, I think we'll just do another quick test render before we amend this rubber material. Okay, just come into the end of it, and 26, shaved another second off. Now that doesn't exactly sound a great deal. However, if you've got a big scene and a lot of reflective surfaces, then it will take a considerable amount off. Now, one of the reasons why we're trying to shave the time off is, like I say, that is one example. However, what we also need to do is we need to increase the amount of glossy samples within this brushed metal effect to get rid of this grain. So I'm going to have to increase these glossy samples up to a value of 16 or 32 or possibly even higher, depending on how smooth we want it. As I mentioned earlier, the glossiness and also the anisotropy values spread these samples out. So the lower these values, the more spread we'll actually get within the samples that are received by the reflection. Okay, so let's just quickly go through this chrome material just to make sure we've got everything set up in there. So maximum distance of 40. I think I'm going to take that down even further, to be honest. I'm going to take that down to 30. Trace depth of 2 is fine. Okay, last thing to sort out is I'm going to just make some quick changes to this rubber. I'm actually going to take these glossy samples down to 4. Might seem kind of an extreme case, however, we only want the shading to be, or the reflections to be subtle anyway. I'm just going to increase that to about 0.5, maybe 0.4, just so we get a little bit of sheen on there. Okay. Last thing I want to do is amend this max distance. Like I say, we only need a subtle value here, so I'm only going to take that down to maybe a value of 15, and I'm going to leave that at 2 as well. Alright, so now if I just knock that out again, so again we had a value of, a render time of 26 previously, and we've still got a render value of 26. Okay, so I think it may have been lower, it may have been closer to 25, but I think we'll leave that at that for the moment. Okay, so we've optimized this down quite considerably. I mean, one other thing to do is to go through and optimize your geometry, because obviously the a lower face count is obviously going to help with render times as well. So detail, for example, within these screws can obviously come down as well. We can obviously take the edge off here, and instead of actually using beveled edges within the actual geometry, we can actually use round corners within this chrome material. Just pull that guy down there. Here we go. As it mentions in the actual rollout, it basically states that it's a shading effect, so we don't actually have physically curved surfaces. If we actually start to get rid of these guys to shave off some polygons here, it's basically a shading technique. Basically says like a bump map. Okay, so I think that's about as far as we can pull this at the moment without getting too heavy within here. However, one thing I do want to do is sort out this roughness within the resulting render. So I'm going to increase the glossy samples up to 16, and now we will notice that the render time does shoot up again. So we've gone from 26 seconds previously, and now we are going to go up to 39 seconds. There we go. So by increasing the number of samples, we've simply doubled it. It hasn't doubled the render time, however it has increased it by a substantial amount in comparison with the original render time. So one thing to bear in mind, like I say, is that the more you kind of increase here, then the more rays that needs to be shot out from those reflections. So one other thing we can do to bring render times down is to start amending the indirect illumination fall off, which it kind of behaves similar to what we've got within this reflections max distance. It in essence clamps off, or fades to and clamps off the ray after a certain distance. However, we don't really have that many bounces, and the scene is relatively small, plus the actual final gathering values is quite low anyway, because we're just using the standard custom value which is applied when you assign mental rate, and that in essence is quite low to start with anyway. Okay, so I don't think we really need to worry about that. Okay, so that's pretty much it for this particular material. However, one last thing that we can do, and it is a extreme case, and that's to use this fast interpolation. Okay, so if we enable that and do another test render, we'll notice that the surfaces are all nice and smooth and nicely blurred out. We can actually reduce the amount of samples in here now, and it gives a nice result. But however, this is only really suitable for stills. Okay, we don't really want to use this for animations, quite simply because it's a fake. It's kind of like a blurry, a pre-render technique, a pre-render method. I mean, the render time now is at 40, so we can shave off some more seconds than that. So by just dropping this, I'm going to drop this value back down to 8, chuck that out again, and we'll still get something that's comparable, but we're going to get a reduced render time even further. Now, like I said, the issue here is basically reflection accuracy. So we'll notice that some of these areas don't fade off and don't blur as well or as accurately as previously. We don't get this kind of feathered effect within the reflection. So what we can do is just come down to this fast glossy interpolation here, so we can refine it, tweak it, improve the quality. And sorry, this is a whole new Q&A really, to be honest, to go through all this lot. However, it's covered quite well within the manual. There's a few examples in there to illustrate the fact that you can tweak one value and tweak another value, and it will be accurate or less accurate, or affect render times or not affect render times based on interpolation grid density. So I say that's something for you to look at on the side. However, the result of it is okay for stills. It can get you out of a bind, it can get you out of trouble. However, another way to get around things, and this is again a different way of working and a different process, is to simply output the reflection as a separate pass and sort out the blur and sort out any kind of feathering based within a compositing piece of software. So we can get non-destructive blurred reflections within the actual compositing software. So you can tweak these values and tweak these blur settings within the comp without baking it within the render and in essence being destructive. What I mean by destructive is the value is set. It's within the render. For you to change that is going to be either a re-render or an exceptionally, not necessarily difficult, but painstaking composite fix. Okay, so you might need to re-render just a chunk and then overlay it within the other renders like a patch job, and then in turn its reflections within adjacent surfaces and so on. So you might need to do this kind of pack job to fix any kind of errors. So one thing to look out for is how to fix these areas and how to control these areas within the compositor, or to make life easier for yourself within the render, try and keep these render times down and try and make things as quick and as effective as possible. Like I say, this glossy interpolation does look nice, but like I say, if you even rotate one of these balls, or if you rotate the camera around the scene, you'll notice some quite nasty flickering going on. Okay, so different methods to attack a single task. Like I say, one additional way to do it would be to have, like for example, a bump map, or very kind of fine, basically like this grain material, grain map assigned within a bump map slot within this special purpose maps rollout, which will in essence distort the map based on shading. It'll distort the reflections, based on shading. However, it doesn't really give an effective result. Now, I know I wrote a Q&A on this around about, I think it was about 4 or 5 years ago or something. However, the end results were quick, dirty, and just kind of again got you out of jail quick. This is a more kind of physically accurate method of doing things. However, like I say, it can affect render times. If you need to just get a quick and dirty method of getting this, getting like a brush metal effect of something that's in the distance, you're not really going to see it, or there's a lot of motion blur or depth of field applied, and you need to see something just kind of in the distance. Like I say, there is a paper that I wrote for 3D World several years ago. Just pull it up. So if I just bring this across here, education page, it's my site, xenomorphic.co.uk/education, and if we go down to, if we can find it, I think I've just gone past it. Have we gone past it? Yeah, no, yes, here we go. Brushed lathed metal. So a couple of visual examples and a little short paper and an example just to illustrate how to get this kind of faked brush metal effect. You'll notice that the reflection is being diffused within this surface because of the bump map. However, like I say, the example isn't really as good as what you're going to get here. Just as a final amendment, what I've done without interpolation is made some final adjustments to this to these materials here, just to bring the values down even further. So I've taken this max distance down to 40, this chrome down to 20, so we're just kind of reflecting the areas around here, and also taking this rubber down even further, down to a value of 5, so it's just the adjacent surfaces, so we're not spreading out even further than we need to. Done another quick test render, and we've actually got a rendering time here of 37 seconds with let's have a look how many samples we've got. We've got 16 samples in here, so the end result is obviously a cleaner brush metal effect. Okay, we've still got a little bit of grain in here, so we might need to increase that even further up to, say, for example, 2432 or something like that. However, we are getting now comparable render times to what we had originally when we were using the full values.